Guys, I'm Manan from Movie Data Scientist, and in this video, we are going to talk about cross-validation. So, cross-validation is a powerful tool in machine learning that is used to evaluate the performance of a model. Cross-validation is a resampling technique that splits the data into multiple subsets and then uses each subset to train and test the model. This allows the model to be tested on the data that it has not seen before. So, ultimately, it helps to identify any overfitting issues. So in this video, we are going to learn about two things. What are different cross-validation methods and how to perform different type of cross-validation. Now let's move forward with our first step, that is importing the necessary libraries. So here, as you can see that we are going to import all the necessary libraries. So we are going to import cross-file scope, cross-validate, k-fold, repeated k-fold, leave one out, leave p out, stratified k-fold, group k-fold, stratified group k-fold, and time series split. So once it is done, now we can move forward and work on our data set. So for this problem, we are going to work on the prediction of mode of failure using an AI network. Let's have a look at the attributes. So there are 5 attributes in the data set. And so let's move forward and download the data set. For that, we are going to use read CSV method. And here is the URL that we are getting the data from. Might take a couple of seconds depending upon the internet speed. So this is the data set that we are going to work on, and this is our target column, that is WC convert. So what we are going to do now, we are going to separate the target column from the training set using pop method. Now let's move forward and run this code. So has been done. Now we can work on the cross validation methods. By far, we have two cross validation methods in scikit-learn. The first one is cross-file score. By default, it uses k-fold or stratified k-fold cross-validation. Then we have cross-validate. So how it differs from cross-file score, we can have multiple metrics and we can have different scoring functions. Secondly, we have more metrics such as fit times and score time that are returned along the test score. Now let's move forward and work on our first cross-validation method, that is k-fold cross-validation. So let us understand how to perform this and what it is actually. So this technique involves splitting the data into k subsets or folds, we can say, of equal size. The model is trained on k-1 fold and tested on the remaining fold. This process is repeated k times with each fold acting as a test set once. The average performance metric across all the k trials is then used to evaluate the model. Now let us understand this validation with an example. Let's assume we have a list of 6 values as we have defined over here. Then we are going to take the value of k as 3, or we can say we are going to take the value of splits equal to 3. Now let's move forward. So this is how we initialize k-fold. Then we are going to see how it actually splits the data. Now let's run this code. So running the code above gave us 3 different group of training tests. As you can see, this is the training one, this is the testing one. So what is going to be done? 3 different models will be trained with training and testing data, and 3 scores will be achieved. So as now we have understood the concept of k-fold cross-validation, now we are going to understand this with different methods. First, we are going to use cross-val score. So in this method, we are just going to define the model, training set, target variable, and the cross-validation method. And it is going to calculate the model accuracy by default. So here, as you can see that we have defined k-fold. We have given 5 slits, random state equal to 100 and shuffle equal to true. Then we are going to implement our random forest classifier model. Here, as you can see that we have defined cross-file score, and inside that we have specified the estimated or the model, which is random forest classifier, the data, the target variable, the type of cross-validation that we are using. So here we are using k-fold and the number of cores required to run this job. So here we have specified -1. It is going to use all the cores. This might take a couple of seconds, so that's why I've already run the code. So as you can see, we have used 5 splits, hence 5 models were trained with 5 groups of training and testing data. We are getting 5 accuracies. So this is how it works, and the mean accuracy can be taken by taking the average of all these 5 values. So this is how cross-validation and the cross-file score method works. Now we are going to work with different method. Now we're going to use cross-validate. So everything is same over here. We have specified the cross-validation method, that is k-fold. Then we have implemented a random forest classifier. Another thing that we have done over here is we have specified our own scoring function. So instead of just using accuracy, we are going to use fn score and the accuracy. And then we have initialized cross validate. Inside that, we have specified the model, the data, the target variable, the scoring function, the type of cross validation, and number of cores to be used. So it actually takes a couple of seconds. So that's why I've already run the code. So here, as you can see that we have received four metrics. The fit time, the time taken to fit the model on the training set; score time, the time taken to check the model performance on the training set; FN score for each five splits; and accuracy score for each of the five splits. So how these metrics are actually useful? So these metrics can be used to optimize the overall speed and reduce the computation cost. So this was all about k-fold cross validation. Now we are going to work on a different cross validation method. So we have understood the concept of k-fold cross validation. Now we are going to work on a different one, that is repeated k-fold. So in this technique, k-fold cross validation process is repeated multiple times. Each time the data set is randomly split into k equal parts or folds, the average performance of the model is calculated over all the repetitions. So now let's take an example. Here what we are going to do, we have taken an array in which we have four values, and then we are going to initialize repeated k-fold in which we are taking number of splits equal to 2. Now let's run this code and split the data into training and testing so that we can see how repeated k-fold works. So running the code above, we saw how repeated k-fold created 20 distinct groups of training and testing dataset with k value or number of splits equal to 2. The only drawback of this method is to train and validate multiple models, which can result in time consumption, and it is actually computationally expensive. Now let's perform repeated k-fold cross validation on our actual dataset, that is motor failure time dataset, and we are going to define our own scoring function. So now let's move along. So here, as you can see that we have initialized repeated k-fold in which we have specified a number of splits equal to 2, random state equal to 100. Then we have implemented the random classifier model. In the scoring function, as you can see that we are taking accuracy, precision, and recall. So you can see that we have specified balance accuracy, precision macro, and recall macro. So when we are dealing with multiple classification problem, we have to either choose from micro, macro, or weighted. So we are going to work with macro in this one. Once we have done this, we are going to use our cross-validate method in which we have specified the model, the data, the target variable, the scoring function that we have specified over here, the type of cross-validation method, so which we have specified over here, and the number of cores to be used. I've already run this code because it's gonna take a couple of seconds to minutes. So this is how the dataset, this is how the output of this code looks like. So running the code above resulted in 20 different values for each metric. So this is how repeated k-fold works. Going to learn about leave one out cross validation. So it is used to estimate the accuracy of a model by removing one data point from the dataset and then running the model on the remaining data points. So let's understand this process with an example. Let's suppose we have a data type with 6 values. Then we apply leave one out. So here, as you can see that we are going to split the data into training and testing. So let's run this code and see the output. So running the code above give us 6 training and testing groups, as you can see over here. We can see that the testing groups have only one value and the same value is not present in the respective training set. So as you can see over here, the training set has one, but the testing set has one, but the training set doesn't have one. So this is how it works. So in case if you have a very large data set, we cannot use this cross-validation method since the number of models to train will increase with increase in the size of the data set. So now let's perform this cross-validation on our main data set, that is motor failure time data set. Take a note that we are going to use the first in values, otherwise we have to implement a lot of models. So here, as you can see that we have initialized leave one out, then we have implemented our model. We are using random forest classifier. The scoring function is same as the above. We have used accuracy, precision, and recall. And then we are using cross-validate method in which we have specified the model, the values, only the top 10 values for both the datasets as well as the target variable, the scoring function, leave one out, and we are taking all the cores for that. So I've already run the code for you guys so that you don't have to wait, but you can pause the video at any point of time and try to implement the code on your own so that you'll be able to understand how does this work. So as we can see that running the code above, we can see the matrix, namely accuracy, precision, recall, and another note to mention that if you're achieving an precision recall and macro of around 100%. This is because we are only validating the data on a single data point. So this was all about leave one out. Now we are going to talk about leave p out. So basically, it is a variation of leave one out, in which we leave out a certain number of data points from the training set and use a remaining data points to train the model. So let's understand this with an example. Here, as you can see that we have data in which is an array, and we have 5 values, and we are going to use leave p out, and we have taken the value of p as 2. So now we are going to split the data into training and testing. So I have already run this code for you guys. So running the code above gave us 10 training and testing groups. So as you can see that in the testing group, we have only 2 values since we have specified the value of p as 2. Again, it's pretty much similar as leave one out. In case if the data size increases, we need to increase the size of p. Otherwise, there would be a lot of model to train, and it's going to take a lot of time and computation power. Now we are going to implement this process on our main dataset, that is the motor failure dataset. So again, we are going to initialize leave p out, and we have specified p value as 2. Then we are implementing the same model, random forest classify. We have taken the same function, accuracy, precision, and recall. So again, we are using cross validate. We have specified the model. We are just taking the top 6 values, and we have specified leave p out, and we are going to use all the cores. I have again run the code for you guys so that you don't have to wait. So as you can see that since we are just training and testing on a very small data set, we are achieving an accuracy precision recall of 100%. It can be different in case if you are using a different model, or maybe you are using a large data set. So this was all about leave p out. Now we are going to work on stratified k-fold. Stratified k-fold ensures that each fold contains an equal proportion of the data. This is really important because it helps to avoid any bias that may be introduced due to the data being unevenly distributed. So let's walk through an example. Suppose we have data that is an array, and we have 6 values. And the target variable says that 9 belongs to class 1, 5 belong to class 2, and much more. Now what we are going to do, we are going to implement stratified k-fold, and we are going to take the splits at 2. Uh, Over here, we can see that we are going to split the data into training and testing. Now let's run this code and see the output. So running the code above, we can see that the ratio of classes 1 and 2 is same in both the training and testing. So let's take an example. Here you can see that 7 belongs to the class 2, and 8 belongs to class 1, and 3 belongs to class 2. In the next example, we can see that 9 belongs to class 1, 5 belongs to class 2, and 6 belongs to class 1. So the ratio of classes remains same in both the training and testing. So this is how stratified k-fold works, and it's really helpful in case if you want to avoid any overfitting situation. Now we are going to apply the same method on our main data set, but we are going to take usually the split value is around 10, but since we are dealing with a really small data set, we are going to choose the value as 4. So this is how the example works. We have taken stratified k-fold, we have specified the splits equal to 4. Then we have also provided another parameter shuffle that will shuffle all the data. And then we are going to implement random forest classifier. Then we have taken the same scoring function, accuracy, precision, and recall. Then we are using cross validate method. We have specified the model, the data set, the target variable, the scoring function, cross validation as stratified k-fold, and number of cores to be used as all the cores. So I have actually just run the code for you guys. So as you can see that average accuracy, precision, recall is around 70%. So this is how it actually works on a real-time data set. You might be getting a different value depending upon the model that you are using, and in case if you are using a different data set, you might be achieving a different value for the same. So this was all about stratified k-fold. Now we are going to work on group k-fold. Group k-fold cross-validation is a variation in this process. Instead of splitting the data into 2 parts, it is divided into k-folds or groups. Each fold is then used as a test set, and the remaining k-1 folds are used as training set. This process is repeated k times, and the average performance of the model is calculated. Now let us walk through an example to understand group k-fold cross-validation. Suppose we have a data set with 6 values. that is named as data. And then we have the target variable in which we have two classes, one and two, and we have also specified the groups in which we have taken just two values, one and two. Now we are going to initialize group key full in which we have taken the splits equal to 2. Then we are going to split the data set into training and testing. Now let's run this code and see the output. So running the code above, we can see that same group is not present in the training and testing set. In this way, this method is useful to detect overfitting situation. So now we are going to work on our main data set. So for that, we need to have a group. For that, we are going to create a list of size 153,000, since that is the size of our data set. And we are taking three splits. So we are going to take values from 1, 2, 3. Once it is done, then we are going to implement a group K fold. We have taken splits equal to 3. Then we have specified our model, that is a random forest classifier. We have the same scoring function. The only difference in the cross-validate method over here is that we have to specify the groups. So again, I have run the code for you guys. So over here, you can see that the average accuracy precision recall is coming out to be around 71%. So again, your results may vary depending upon the selection of your machine learning algorithm and the dataset. So this was all about group K fold cross validation. Now we are going to work on a different method, that is stratified group K fold. Stratified group K fold cross validation is a combination of the above two methods. The dataset is split into K subset or folds, and each fold is stratified according to the population. This ensures that the fold contains a representative proportion of the population. The model is then trained on K-1 fold and testing on the remaining fold. This process is repeated K times and the average performance of the model is calculated. Now let us walk through an example. So example is exactly pretty much the same. We have a dataset with 6 values, that is an array. Then we have the target group in which it belongs to two classes, 1 and 2. And we have also taken a test group in which we have two values, 1 and 2. So what we are going to do over here, we are just going to initialize stratified group K fold, and we have taken in splits equal to 2. Now let's run this code so that we will be able to see the training and the testing groups. So running the code above, we can see that the same group is not present in our training and testing, and the idea is to try to preserve the distribution of classes in each split while keeping each group within a single split. In order to work in our main dataset, we are going to create a list of groups of equal size of the dataset, and the unique value would be equal to the number of splits, that would be equal to 3. So here, as you can see, that we have specified the value of n splits equal to 3. And then we are going to implement the same model. We have taken the same scoring function, and the only difference is we have just specified the groups over here in the cross-validate function. So I have run the code for you guys so that you don't have to wait. And again, we are achieving an average accuracy precision recall value of around 71%. So this was all about stratified group K fold. Now we are going to work on another cross-validation method, that is time series split. So time series split cross-validation is a specific type of cross-validation technique that is used to evaluate the performance of a model on a time series data. It works by splitting the data into multiple sets, usually a training set and a testing set. The model is trained on the training set and tested on the testing set. Now let's understand this with an example. Suppose we have a dataset with 6 values and we apply time series split on this dataset with 3 splits. So here, as you can see, that this is our data. We have specified time series split and n splits equal to 3. Now let's move forward and run this code. So from running the code above, we can see that time series split have splitted the data into increasing time frame. In the first group, we have 9, 5, 6 in the training and 7 in the testing. Then again in the training, we have 9, 5, 6, 7, and in the testing, we have 8. Again in the last group, we have 9, 5, 6, 7, 8, and in testing, we have 3. So this is how time series cross-validation works. So these are the mostly used cross-validation method. We have gone through example and we have implemented these method on real-time dataset. So this was all about cross-validation. In case if you have liked the video, please subscribe to the channel and like the video and share it to your friends. If you want to learn more, you can go to moredatascientist.com and you can feel free to apply for any courses that you would like. Thank you.